Let's start. So this session is streams and media. So this session is to introduce recent updates on the streams API, including collaboration with media APIs, and to discuss future projects. So one is readable byte stream. So you can read bytes into a uint8 array, which is provided by the stream user, so that it allows the user to recycle the buffer, which leads to smaller GC cost, and it allows the user to specify the size of the buffer. And we shipped this in M89. So here is an example code. So we create a new array buffer here, and we put a typed array associated with the buffer, and when we call readable reader.read, the buffer is detached and given to the stream, and we get the buffer as the return value of the. So here is result of the benchmark. So it depends on the size of the buffer, but due to the reduced cost of the GC, we got the 9 times faster reader with the readable byte stream. So as I said, we shipped the feature, but each native byte stream needs to enable this feature. So so the fetch API, blob, serial API, web transport, these API need to enable this feature to provide the byte stream feature. So these are needed to be done. Okay. Another feature is transferable streams. It allows users to transfer streams across realms. It relies on message port to exchange data and signals, and it copies every chunk. So here is an example. We create a readable stream, we create a worker, and we can transfer that stream to the worker. On the worker, we can get the message event here, and the readable stream is stored in the message. So we can create a reader and get chunks from the reader. We shipped the feature on M89, 87, sorry. So this is a diagram for the transferable streams. So this is an example for transferring a readable stream, RS. So the upper left is the original source and original readable stream, and the system creates a pair of writable stream and readable stream. On the writable stream is on the source realm, and the readable stream on the destination realm. And the created writable stream and readable stream communicate with the message ports. And the original readable stream is piped to the created writable stream, and you can read chunks on the destination realm. So there is no magic. Uh, a you can create a similar library with JavaScript, but it respects back pressure, which is hard to implement, and it allows optimization for native streams as follows. So as I said, transferable streams copy each chunk on the source stream. So the chunk reading in the destination thread is blocked on the source thread. This is undesirable and needless for certain native streams. Here, I mean native streams by streams provided by the browser. So we can develop an optimizer for such native streams. So it's useful for APIs that can only be available on the main thread, but benefited by thread offloading. So there are two kinds of optimization. One is per chunk transferring. So we can transfer each chunk instead of cloning. So which reduce the cost of cloning. And another is so when the source is not bound to the source realm. So instead of reading chunks on the source realm and transferring or copying it to the destination realm, we can directly connect the source and the readable stream on the destination realm. So for example, um, when you when we handle streams of events, streams of data which are coming from the browser process, so we don't need to read every chunk on the main thread to transfer them to the worker thread. Instead, we can read the chunks on the worker thread directly. So we are working with media people, and we implemented the optimization on the media stream track processor API. So here are some demos, and here is a result of the performance benchmark. So that when we transfer individual frames, so when the main thread is busy, the frame rate drops. But when we transfer the entire stream, the destination thread is not blocked on the main thread. So the in this case the frame rate is stabilized. And we are thinking of some future projects. One is transferable streams v2, so that it allows the stream users to transfer chunks. And there are abortable reads and abortable writes, which are requested by serial API and web transport. And some media people, so that web transport and the web codecs both use streams, and some media people are wondering whether we can use them efficiently, so that we may want to implement some optimization for the pipe to operation. So that's the end of the presentation. Do you have any question, suggestion?
I thought Web Codecs decided not to use streams in the end.
I see. That's unfortunate.
Okay, I thought maybe they changed their mind and you knew, but maybe not.
All right, if there's no questions, guess we can wrap this session up earlier.
Thank you for coming.